On your Unit 2 review, problems 41 and 42 you can skip. We did not do those. 41 and 42 you may skip. And 47 and 48 we did not do. So you can skip 47 and 48 today. Okay? So 41 and 42 skip. 47 and 48 skip. All right? So what questions do you have? Lexi. Okay, so everyone go to number 25 with us, even if you've already had it done. Yes, Cade. Okay, number, what, 25 you said? Okay, so 25 says to simplify this. So this would have been lesson 2.5B, I believe, 2.5B. So we are just combining like terms here. There is no multiplication going on. We're not doing distributive. We're just combining like terms. So I'm going to rewrite this as 5i. And then remember, when you subtract, you're actually changing the signs here, right? So that's going to be a positive 4, negative 6i, minus 4. Are you okay with that? Now we're just combining like terms, right? So 5i and negative 6i make negative I. 4 and negative 4, well, that's gone. So the only option there is negative I. Does that help with that series of questions? Okay. Ryan. 45. You want me to do this all the way out with you, or you need help getting started?
Oh, this is about elimination.
Okay, how did you get started? What did you get rid of? With the t's? Are you eliminating t? Okay, so you took the first equation, and then what was your second step? The first and the second one? Okay, so I'm going to flip-flop here. I'm going to do the first and second one first, okay? So everyone has a piece of paper. You're writing this down. We're going to take these two equations, and we're going to write them out. That's going to eliminate our t values, okay? So step number 1. I'm just rewriting the equations down. And then okay. So this will help us to eliminate our t values here. And now I add. So when I add negative 3r plus 2r, that gives me negative r. S minus 2s is minus s equals negative 6. Is that what you have in one equation? Maybe that was the issue, huh? Okay. Second step is to take another two equations. But if you eliminate t in step number 1, then we have to eliminate t again. So, Ryan, you did the first and the second, right? Or the first and the third? And you multiplied this row by what? To get rid of the t's, right? Because if that becomes a negative 2t, then it's going to cancel out with that positive 2t. Okay, so step number 2. I'm distributing a negative 2 through the entire top row. Okay? We're distributing a negative 2 through the entire top row. So that gives me 6r minus 2s minus 2t equals 20.
So I'm confused. Why? Like,
We're trying to eliminate t's again. So if we eliminated it here, then I have to choose another two equations to eliminate t with. Okay? So if this one's a positive 2t, I need this to be a negative 2t. And if it's a negative 2t, then the t's will cancel. Okay? So then let's go ahead and write our third equation down on top of that. Negative 6r minus 5s plus 2t equals negative 27. Now we can add these two rows together. And this time, actually, my r's cancel as well, right? So I have negative 7s equals negative 7. Now, typically, I would also have an r here, right? I would have an r here usually. And then I would bring these two equations together and do some elimination there. But do I need to go that far here? Because I can go ahead and solve this for s, right? And we get s to be 1. Where are we going to plug it back into, Lexi? Okay, if I plug s back in here, I'm still missing r and t. Okay, so Lexi's saying, hey, if you plug s in here, then you'll be able to find out what r is. Okay, so I'm going to let you guys finish this out then. So you know where to go, plug it back in. What other questions do you have on your review? So put a pause there. What other questions do you have on your review? Page 1?
No, 31.
31. Okay. So everyone go with me to number 31, please. Taylor, help us out with 31. What are we going to do first on 31?
The first thing you're going to do is you're going to times the I, that would give you I squared.
Okay. Typically, what did you want to do first, though?
I wanted to distribute.
We are so ingrained that whenever we see parentheses, we distribute, right? That's how our brain has been taught. But we need to go in order from left to right. That's what PEMDAS teaches us. Go in order from left to right. And as I go in order from left to right, I actually need to take care of this multiplication first. So I times I is I squared, 4 plus I. And then we said I squared is really what? Negative 1. So I'm going to change that to be negative 1. 4 plus I. If I'm writing this down on your review, you should be writing this down on your review too, not just staring. This is interactive. Even if you're not here yet. And then you can distribute your negative 1. Okay? Does that help, Daniel?
Yep.
Okay, what else?
Actually, I'm actually curious that could we actually distribute first and then do the steps, or would it turn out
Why don't you
wrong?
check to see if you get out to be the same answer? Why don't you do that on your paper and see if you get the same answer?
And we tried 17.
17. Ooh, good one. Okay, what do we do first on 17? No. What do you do very first thing? Thank you, Donald. Set it equal to 0. That's the very first thing, is set it equal to 0. So I'm going to subtract 20x. And I'm subtracting 32 because I want my x squared term to stay positive. So I'm going to move things over to the left side of the equation. So I have 25x squared minus 20x minus 32 equals 0. Now we try to look for the greatest common factor. Is there a greatest common factor here? There's not. So, here we go. What is 25 times negative 32? Anyone? Negative 800. And they have to add to get negative 20. Okay, extra credit for the person to find the pair. Oh my gosh. She's already there. 20 and negative 40. Someone verify Leanna, please. Yeah? Okay, so can you just split the middle and put x plus 20x minus 40? Can you just put x plus 20x minus 40 here?
No.
Vinny, why not? Why can't we just put x?
Because there's no 1.
Thank you.
Yeah.
This value is greater than 1, right? So I'm going to have to split the middle. So I have 25x squared. What's going to go better with 25x squared, 20 or negative 40? Not really going to matter here. So we can just put plus 20x minus 40x. What's the last number? Negative 32. Okay. You can finish that out. Lena?
I do have a question.
Sure.
On number 46, I know we can argue that one, but I got the money equation, the simple equation. I'm having problems with the complex equation.
Okay. What number was it?
46.
Okay, put a pause on number 17 and go with us to 46, please. So a lot of this is me getting you started and then you finishing it.
I got negative 5.
Which in this one, this is negative 4 minus I, which is not the same thing. All right, jambalaya is a Cajun dish made from chicken, sausage, and rice. Anyone ever been to New Orleans? That's where
You said that all
jambalaya
so
came from.
fast, I lost track.
Okay, Simone is making a large pot of jambalaya for a party. Chicken costs $6 a pound, sausage costs $3 a pound, and rice costs $1 a pound. She spends $42 on 13.5 pounds of food. All right, so Leanna, what's our first equation?
Well, do you want to know what I labeled everything as
Sure.
first? My C is going to be chicken, S is going to be sausage, and R is going to be rice.
Okay,
And then,
C-S-R, all right?
And then I have 6C plus 3S.
Hold on, slow down. 6C, so that's 6 pounds per chicken plus
3S
$3 per pound of sausage
plus R.
plus 1R or just R. And this is all the money, right? $6, $3, $1, so it should equal money. So this is our money equation, right? Remember when we did these, we always had a money equation, a simple equation, and then we had one that was a little bit more complex. Okay? So then the next equation says what? We have a simple one, right? So it should be
C plus S plus R equals 13.5.
okay. So it said we had 13.5 total pounds of food. So I know that the pounds of chicken, pounds of sausage, pounds of rice should equal 13.5 total. And then it says she buys twice as much rice as sausage. How can you represent twice as much rice?
Second power.
What'd you say? 2R, not the second power, just 2R. As sausage. What does as mean in math? Equals. Twice as much rice as sausage. But we don't like to see it in this order. So what can I do with this S? Subtract it over, right? So when I subtract it over, I have negative S plus 2R. And then this just becomes what over here? 0. And then you can solve from there. On this one, you don't need to solve this one out. You just need to be able to set it up. So this was a practice getting it set up. You don't need to solve this one out. Okay, I'll take one more question.
I was actually curious about 35, although this is a simple one. I want to make sure, I was curious about after you got the I to the outside of,
Okay, good question. 35. First of all, when we see a negative underneath the square root, what do we have to do first? Take the I out. So this is I square root of 160.
I got that far, but I
Okay.
wasn't sure where to go from there.
How do you break it apart? Find any two numbers that make 160, right? And the easiest way to do that is 160 is an even number. So what can go into 160?
8 and 20.
If it's an even number, if it's an even number, what number will always go into an even number?
2.
2. So if you don't know whatever else, just pick a 2 and keep going from there. But, Taylor, what'd you say?
8 and 20.
8 and 20. So let's go 8 and 20. Write it on your paper. Then what makes 20, Crystal?
5 and 4.
Okay. Can one of those be broken down?
4 can.
2 and 2, right? What about 8? What are you going to break 8 down to?
4 and 4.
4 times 4 is 16.
Wait. Oh, 2 and 4.
Okay. So I have a pair of 2s, another pair of 2s, and then I have this 2 and 5 that didn't get broken down. So for your pair, you write it how many times on the outside, guys? Once. So how many 2s are you actually writing on the outside? 2 of them, right? So you have a 2, and we multiply. Then whatever didn't have a pair goes back inside. So I have a 2 and a 5. So 2 times 2 on the outside is 4. Square root of 10. What am I missing?
Your I.
The I.
Wait, couldn't we have just skipped breaking down the 4s since
You had a pair of 4s here?
Yeah.
Yes.
Can we just skip that?
Yes.
Okay.
Lexi? That's when you're the plus or minus in front of it. That's when it's just x by itself. Like if you have x squared equals -4. Okay. I don't think you have them on the test though. All right. I'll take one last question. Anyone who want to ask one last question?
Can you do 3 or 4?
Graphing is on the test.
What number?
3 or 4. Let's do 4 together. Guys, you know the difference between standard form and vertex form, right? Let's write this in your notes somewhere on your paper. This is standard form. And we have to do y equals ax squared plus bx plus c. Write that down on your paper somewhere, even if you already know this.
You said y equals what?
It's written up there on the board. Y equals ax squared plus bx plus c. Vertex form is this. Y equals a times x minus h squared plus k. So if I'm looking about how to find the vertex on each of these, how do you find the vertex when it's in standard form? Negative b over 2a. And then we plug back in, right? How do you find the vertex when it's in vertex form? Where do you find your vertex in vertex form? Say that again, Aspen. The H and the K, right? All you're doing is pulling it from here. There's no work to be done in vertex form. This has been, as I've been working with you, this has been one of the most confusing things for you guys. I don't know what to do. Well, first of all, you have notes to look back at. But this is standard form. This is when you're doing opposite of a over 2a. This is vertex form, where you just pull the vertex from the equation. What do you have to remember about the h value here? It needs to be the opposite sign. Right? So if your h here was -3, you would make that a +3. So number 1 and 2 in your study guide are vertex form. Number 3 and 4 in your study guide. Number 3 and 4 in your study guide are standard form. You need to know the difference between the two of them. So number 3, is, I'm sorry, number 4 is which kind? Standard. How do you know the difference? Do you see the difference here in these equations? This one has parentheses, right? And it's got a squared here. This one is just ax squared bx and c, okay? And if you look at the differences, like look at 1 and 2, and then look at 3 and 4. Do you see how the equations look different? Like in 1 and 2 you have parentheses with a squared, and then in the bottom ones you don't. Okay, so that's how you tell the difference. So on number 4, we're going to start by doing the opposite of b over 2a. That's how you find your vertex. So my b value is 8, so it's going to be a negative 8. My a value is negative 2. Negative 8 over negative 4 is what? 2. Positive 2. What do we do with that positive 2? Can you write down with me, please? Okay. What do we do with that 2? All right. So we know that the first coordinate of our vertex here is 2, comma something. So to find out what that other variable is, we're going to take a 2, and we're plugging it in here for x and here for x.
And
All right.
we just do basic addition after we multiply those out.
So negative 2 times 2 squared plus 8 times 2 minus 9. All I did was take the 2 value and I plugged it in here. So negative 2 times 4 plus 16 minus 9. So negative 8 plus 16 minus 9. That gives me positive 8 minus 9 is negative 1.
And our x value would be 2, right?
The x-axis, or the axis of symmetry, yes, is going to be 2. It's always whatever that first coordinate of your vertex is. Is this going to open up or down? Down. How do you know it's opening down? Because the a value up here is negative, right? Which means it's opening down. If it opens down, does it have a minimum or a maximum?
Maximum.
Maximum. So let's graph this one. 2, negative 1. It's opening down.
Now, I have a question about when you graph it, because I get confused. Can it cross the y-axis?
Yeah, actually it should. What's the y-intercept here? So who said that? Negative 9, right? Remember the c value? Whoa.
Oh, okay.
That c value. So actually this one should be crossing at negative 9.
That's what confuses me. I'm like, well, I don't know if I should
They
just
must
draw
my
a
brow
line
is a little
or-
bit lopsided views.
It's okay, I'm not really worried about your shape. Here's one last thing that we haven't talked about in a while. How do you find the domain and range of this parabola?
Oh, wow.
Okay, so let's think about, we did a little bit of this yesterday actually. Think about your domain. Your domain is all the values of what? X. So if your parabola is going down, what's happening? It's going to hit all of them eventually, right? It's going down and it's going to eventually spread the entire x-axis. So what would we write there for the domain?
Negative infinity,
Good.
positive infinity.
Good. See, you guys are remembering this. What about your range? Remember, range goes up and down. Is it going to go, where's it going off to at the top? Is there a stopping point at the top?
Yeah.
Where does it stop at?
-1.
Negative 1. What about to the bottom?
Infinity.
Infinity.
Negative infinity, right?
Right.
So we know that we're going from negative infinity all the way to negative 1, and it stops there.
Surprise review.
All right.